Do you have a friend who adds way too much sugar to their coffee? What would happen if they added so much sugar that no more would dissolve? Let's take a closer look. This is real chem. We often think of math as being all about the numbers, multiplying, dividing, taking the log, but graphs can be so powerful and allow you to make quantitative predictions. So how does this apply to dissolving sugar? Vamos a mirar juntos. Let's explore. As you add sugar to water, the sugar initially dissolves, but at some point, the solution becomes saturated, and any additional sugar accumulates at the bottom of the glass instead of going into solution. At this point, we say the solution is saturated, and we call the concentration of this saturated solution the solubility. More generally, when we dissolve a compound in a liquid, we refer to the compound we are dissolving as the solute and the liquid as the solvent, and we can determine the solubility of any solute in any solvent. The solubility is dependent on both the compound being dissolved and the solvent. In addition, the solubility depends on the temperature of the solution. For most substances, the solubility increases with temperature, and we can sometimes use this to our advantage. The solubility of sugar in water has a strong dependence on temperature. We can use this to make rock candy. Here's how. We start with 100 milliliters of boiling water and add sugar until we make a saturated solution. At 100 degrees Celsius, we get a saturated solution when we have added about 480 grams of sugar. That's a lot of sugar. We then let this solution cool to room temperature. At room temperature, the solubility of sugar is only about 200 grams per 100 milliliters of water. So we have 480 grams minus 200 grams, and we get 280 grams. That is 280 grams more sugar in our water than would be present in a saturated solution. We call this a supersaturated solution, and it is unstable. Eventually, the extra 280 grams of sugar will come out of the solution, forming solid sugar crystals. To make rock candy, we want that extra 280 grams of sugar to crystallize onto a string or a wooden stick. By coating our string or wooden stick with sugar, we can encourage this process. This is related to why the extra 280 grams of sugar initially remains in our supersaturated solution. A sugar crystal has a specific arrangement of sugar molecules, and it can take a long time for the first group of sugar molecules to arrange themselves in a specific pattern. This slow initial stage of crystal growth is called crystal nucleation. But once a small crystal has formed, other molecules add to this crystal and we get rapid crystallization. We say that a small crystal is a seed because just like a seed grows into a plant, that small crystal seed eventually grows into a large crystal. By coating our string or stick with sugar, we can seed the crystal growth. In addition to accelerating the crystal growth, our seed helps ensure the crystals grow where we want them, on our string or our wooden stick. So what have we learned? Yes, there's an upper limit to the amount of sugar your friend can put into their coffee. And it also depends on the temperature that coffee is served. My advice? Keep supersaturated solutions for the lab. And look after your teeth. Vamos a explorar. Y no se te olvida tener fun. So explore and remember to have fun.